Good morning or good afternoon, depending on what period you have math. Mrs. Kitchell is out today, and this is Mrs. Kramer, and I will be teaching you Lesson 3, Rational Numbers on the Number Line. Okay, first let's start off by defining a rational number. The set of rational numbers includes all positive numbers, negative numbers, and zero that can be written as a ratio, or a fraction, of one number over another. Whole numbers, integers, fractions, terminating decimals, and repeating decimals are all rational numbers, okay? That's a lot probably to understand from a definition. So let's go over some examples so you can actually see what rational numbers are. Okay, example 1, graphing rational numbers. Okay, it tells us to locate and graph the number 3/10 and its opposite on a number line. Well, let's first talk about the opposite of 3/10, okay? You guys learned yesterday that the opposite of positive 3/10 is negative 3/10, okay? So now we have a number in its opposite. How many sections would the distance between the whole numbers need to be split into? Okay, so we have a number line here. It has 0, positive 1, and negative 1, and we need tenths, okay? So the denominator of a fraction tells you how many pieces it needs to make a whole. So this whole here has to be split into tenths. This whole here also has to be split into tenths. So we need 10 sections, okay? In order to make 10 sections, we actually are going to make 9 lines, okay? And I'm going to show you why. 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? So if I was looking here at the sections, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. So this would be 1/10, 2/10, 3/10, 4 out of 10 sections we have just gone over, 1, 2, 3, 4, 5/10, 6/10, 7/10, 8/10, 9/10, and this would be 10/10 or 1. We have to do the same thing on the other side, on the negative side. We have to split this 1, 2, 3 into 9 sections. 4, 5, 6, 7, 8, 9. We have to split it into 10 sections with 9 lines. You always make one less line than the total number of sections that you need. So if you go down one of these spaces, you're down negative 1/10. This is negative 2/10. This is negative 3/10, negative 4/10, negative 5/10, negative 6/10, negative 7/10, negative 8/10, negative 9/10. Okay, beautiful. Okay, so those are all rational numbers. There are not so many little numbers or pieces in between every whole. Okay. Our next direction is to now go back and label each location with its decimal equivalent. Okay, this is pretty easy. But before I do that, I'm going to locate 3/10. And I'm going to locate negative 3/10. Now, what makes these opposites of each other? It all has to do with this guy right here, 0. These are equal distance away from 0. That means they have the same absolute value, okay? Now I'm going to go and do decimal equivalents. 1/10 I know is written like this, 0.1. That's 1/10. You could also do 1 divided by 10, if I have my math tools out, with your calculator, just to show you another way, just in case you ever get nervous about I don't see my math tools. Oh, okay. About changing a fraction into a decimal. 1 divided by 10. 1 divided by 10 is 0.1. Okay. Now this 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1 whole. Okay, now we'll do the same thing counting in the negative direction. You're down 0.1 or 1/10, down 2/10, down 3/10, down 4/10, down 5/10, down 6/10, down 7/10, down 8/10, down 9/10, down a whole. Okay, these are all rational numbers. 1 is rational. All of these fraction or decimal pieces rational. Okay, so that's a great introduction, okay, to rational numbers. Let's go on to the next example. Example 2, graphing rational numbers. Come on, computer. Okay. Use what you know about the points, -7/4 and its opposite, to graph both points on the number line below. How can we write -7/4 differently? Okay, well, -7/4, I see my numerator is larger than my denominator. So it really says 7 divided by 4. 4 fits into 7 one whole time, and there's 3 left over. That means -7/4 can also be written as -1 and 3/4. Okay. The fraction -7/4 or -1 and 3/4 is located between which two consecutive integers? This is very tricky. Okay. I'll show you where -1 and 3/4 is. This means you're down 1 and an additional 3/4. So if you start at 0 and you go to being down 1, okay, it's going to be in between these two numbers because you have to be down 1 and 3/4 more, okay? So it's going to be in between -1 and -2 because they want me to go down 1 from 0 and an additional 3/4. Down 1 and 1, 2, 3 out of 4 sections. This is where -7/4 or -1 and 3/4 is going to be located. Some kids make a mistake and say, oh, -1 and 3/4, that's right here. No, no, no. You have to start at 0 and go down -1 and an additional 3 out of 4 pieces, okay? Now go back and label each location with its decimal equivalent. Well, first thing I would have you do is do them all with fractions. Count how many pieces make a whole. There are 1, 2, 3, 4 sections that make a whole. So this is 1 out of 4 pieces, 2 out of 4 pieces, 3 out of 4 pieces. This one also has 1, 2, 3, 4 pieces that make a whole. This is 1 and 1/4, 1 and 2/4, or 1 and 1/2 if you simplified it, 1 and 3/4. Okay, I'm not going to worry about simplifying right now in the intro lesson, okay? But now there's also 1, 2, 3, 4. Every single one of these is going to have 4 pieces that make a whole. So this is down 1/4, down 2 out of 4 little sections, 1, 2. This is down 3/4. Okay, -1. Now you're down -1 and an additional 1/4. Now you're down -1 and 2/4. Now you're down -1 and 3/4. Okay, so now I'm going to take out my calculator because I love it. You can take yours out too. Okay. I'm going to change this fraction to a decimal. This is 1 divided by 4. Okay, this is going to be 0.25. Okay, 2 divided by 4, 0.5. 3 divided by 4, 0.75. And this is just 1. And you can get used to 1.0. It's 1 and no fractions if you want to. Now, since I have these 4 already done, these are a piece of cake because it's 1 and 1/4, so it's 1.25. 1.5 for 2/4, which scales down to a half, or 2 divided by 4. Okay, 1 and 3/4 is 1.75, and then 2.0. Okay, and we're going to go down and do the rest here. And I just have to copy now that I have all of these positive ones. This is negative 0.25, negative 0.5, negative 0.75, negative 1.0, negative 1.25, negative 1.50, negative 1.75, and negative 2.0, just so you get used to doing that. Wow, that's a lot of tough work. But thank you for sticking with me. Let's do the last example before you guys have to go to your EduCanon, okay? It's kind of cool that I'm teaching Team 2 kids today. Okay, example 3, graphing rational numbers, okay? Label the following number line with both decimals and fractions, okay? Make sure that your number line includes 1 3/5 and its opposite. How many sections would the distance between the whole numbers need to be split into? Well, I'm going to start here. 1 3/5. Its opposite, negative 1 3/5. Okay? So I always look at my denominator of my fraction. It tells me so many things. It tells me that 5 pieces make a whole. So in between your holes, every single hole, you need 5 sections. So how many lines make 4 sections? 4. 4 lines in between every hole are going to make 5 sections. 1, 2, 3, 4. So that's 1, 2, 3, 4, 5 sections. Let me count that. 1, 2, 3, 4, 5 sections that make a whole. I'm going to make 4 lines here. 1, 2, 3, 4, 5. I'm going to make 5 sections here. Ooh, Mrs. Kramer. Yep, I did that right. Okay, always double check my work. And then 4 lines here to make 5 sections. Now I would like you and your partner to pause it to try to do this on your own. And then I am going to pause my video and do it. Then when you think you have all of the fractions labeled on the bottom and all of the decimals labeled on the top, you can hit play. So hopefully you and your partner had a lot of success labeling these. I think the best way to do it is to label them with the fractions first. Your 1 up 1/5, up 2 out of 5 pieces, up 3 out of 5, 4/5, okay? And then don't forget to use your calculator, okay? If you need to change these to decimals and you're not really sure how, you can do 1 divided by 5. Okay, it is 0.2. Let me remind you, too, of another way you can change fractions to decimals, okay? You can also use equivalent fractions or equivalent ratios, because I know decimals can have a 10th denominator. 5 times 2 is 10, and whatever you do to the bottom, you must do to the top. So you can have 2/10 or 0.2, okay? So two different ways to get the same answer. Now the last question, is there another way this number line can be labeled with decimals and fractions? Well, sure. I mean, I guess you could change any of these things, any of these denominators. 1/5 could get changed to a denominator of 100. Okay, 5 times 20 is 100. 1 times 20 is 20. So it could be 20/100ths or 0.20. I'm going to leave this question for Mrs. Kitchell to help explain more, okay? Now, if I scroll down, she left you another number line. I'm going to let you guys skip that one, okay? And you know what else I didn't do? Negative 1 3/5. Okay, you have to put a dot on your line to make sure that you know where it is. And then 1 3/5 is all the way down here, okay? So I'll let you skip that last one and work on with her. And you may now proceed to EduCanon, okay? And try to do all of these. And you have to label all of the number lines, break them up into pieces just like we did. And there are some review questions, okay? Good luck.